Here we're going to look at number 2 and number 4. So we have a 20-liter cylinder. A 20-liter cylinder contains gas at 6 atms and 27 degrees. What would the pressure be if the gas is heated to 77? So our cylinder we're assuming is constant, and so we really don't care about that number there, right? So we know that we start off at 6 atms and 27 degrees. We want to know the pressure, P2, if the gas is heated to 77 degrees. Well, we're in degrees Celsius, and we know that in our equation, temperature has to be in Kelvin, even though they match up. Pressure doesn't matter, they just have to be the same. Volume just have to be the same units, but temperature has to be in Kelvin. So I'm going to use my equation to change, right, or convert. So 27 plus 273 gives me my new T1, and 77 plus 273 gives me my new T2 that I can plug in to my equation as T1 and T2. Right, we know P1 was 6. Just like that last homework, if we're solving for P2, we need to cross multiply. So 6 times 350 gives us 300 times P2. Divide both sides by 300, and because this is only one significant figure, 6 atms, I round my answer to 1 sig fig. Right, so we know that when the temperature increases, the pressure is going to increase, and it did. It went from 6 to 7. On number 4, right, find the temperature in Celsius. So there's going to have to be a unit conversion at the end, needed to change the pressure of 10 liters of gas, right? That has a pressure of 97 and 25, and it starts at this standard pressure of 101. So first of all, right, the 10 liters of gas, that doesn't change, so we can ignore that. We know that the pressure at 97 is at 25, so those two are grouped together. Right, 97 kilopascals at 25 degrees Celsius. And then we want to find the temperature in Celsius needed to change the pressure from, right, if it gets to this standard pressure of 101.325. So we know that we are looking for the temperature when our pressure goes from 97 to 101.325. Right, if it's starting out at 25 degrees Celsius. So we've got to convert. So we convert that to Kelvin. Of course, you got to write down your equation to get all your points. That goes with the essay questions in your exams. So now we are just going to plug in those numbers, right? So this process, even though it's not mandatory, it does make this step so much easier, because now I'm really just doing math after this. I'm just plugging in numbers and solving for it. Okay, now if the pressure went from 97 to 101, what has to happen to the temperature? Well, right, it has to increase. It has to get greater because the volume is going to stay the same. So we plug in our numbers. As before, we cross multiply, right? So 298 times 101.325 and 97 times T2. We divide both sides by 97. Notice that up here, again, this is 3 sig figs and 2 sig figs and 6 sig figs. I don't care about the 10 because I didn't use it in any calculation. So my final answer is going to go to 2 sig figs, but this, because I'm not done, is to 4 sig figs. I'm going to plug that in back into this equation. Right, that's what I'm using here in step 6, except for now I have my temperature in Kelvin. So now 311.3 minus this 273 is going to give me my degrees Celsius. And as we said, because that 25 degrees Celsius is the least amount of sig figs, we round to 2 sig figs and make sure we've got units on that answer.